Okay, let's have a look at how to do something called dividing polynomials. So hopefully by this point we know what a polynomial is. It simply means an equation containing just one variable, in this case, so for example, x cubed plus 6x squared plus 8x plus 3. This is a polynomial. And when we talk about dividing polynomials, we're essentially talking about doing long division to divide something with x into something else with x. Now, a couple of things to note about this. First of all, we can only divide two polynomials, at least in this method, whereby the highest exponents, so by which I mean the highest indice that we see in this equation, so it's 3, is greater than or maybe equal to the greatest exponent in the thing we're dividing by. So we can't divide an x cube equation by an x to the 4 equation, at least not in this method that we are looking at now. So if I were to say, I wanted to divide this whole thing here by x plus 1, how on earth would we do that? Because when we think about factorizing out cubics and quadratics, we tend to end up with, for a cubic, 3 things that look like this. X plus or minus integers, maybe sometimes you might have something stuck to the x. So how can I work backwards and divide? Well, the way that we do this is using some algebraic long division. So I'm just going to kind of work with the top of my board here, and I'm going to write this as if I was doing some bus stop method standard long division. So a bus stop over that, and then what I'm dividing by goes here. X plus 1 into x cubed plus 6x squared plus 8x plus 3. The strategy to do this, once you get the hang of it, is relatively straightforward. It's just about being able to get the hang of it and being able to write it out in a very, very specific way. So the very first thing I'm going to do is I'm going to take my first term, in this case x cubed, and I am going to divide it by x. I'm going to cut one of the x's out, and I'm going to replace what I'm left with up top. So I'm left with an x squared. I'm just cutting one of the x's out. I'll show you some examples in a bit where we don't have a 1 in front of this x cubed, maybe we have a 2 or a 3 or a 4. But all we need to know is we need to get rid of one of the x's. Reason for that is we know when I divide something with a cubed in it by something with just an x in it, I'm going to end up with a quadratic, and solely a quadratic. So I've got that. Now what do? Well, I take what I've got up here and I multiply it by my divisor. So I take the x squared and I multiply it by the x plus 1. I'm going to write that out beneath here, and you'll see why in a second. X squared times by x is x cubed, plus x squared times 1 is x squared. And the reason, and it's very, very important that you write this out in a very specific way, it's very important that you map our x cubed terms on top of each other and our x squared terms on top of each other. Okay? Because once I've got this written out, I'm going to minus this equation I've just written by this equation, or rather, other way around, minus this red equation by this green equation here. And when I do that, if I've done it correctly, I notice that my first term should cancel. So I have an x cubed minus an x cubed, which is 0. Then I have a 6x squared minus an x squared, so I get plus 5x squared. Then what I do is I kind of go back to the start, and I pretend that this was my starting point, and I redo everything again. So what was the first thing I did here? Well, I divided this x cubed by x, so I'm going to divide this by x. When I divide this by x, I get 5x, and I'm going to add that to the top. Same thing I did to the x cubed. I divided it by x and I added it to the top. So here I've reset, I've divided this by x and I've added it to the top. And I'm going to go through the same procedure again. I'm going to take the thing on the top and I'm going to multiply it by my divisor. So 5x times x is going to be 5x squared, and 5x times 1 is going to be plus 5x. And then, same procedure, I'm going to minus things. Now, something we want to note is that first of all, we've got 5x squared minus 5x squared is 0 again, but then what happens to this 5x? Because there's nothing actually above it, right? Well, this is where the rest of my equation comes in. I have a 5x here, so I would like to minus something with an x. And what have I got with an x? I've got an 8x. So I'm going to bring my 8x down here, and I'm going to pop him up there. So I end up with 8x minus 5x gives me 3x. And now I'm going to repeat the procedure again. I'm going to take my 3x, I'm going to divide it by x, and I'm going to put what I'm left with up top. 3x divided by x is just 3, and on top I end up with x squared plus a 5x plus a 3. Now what I need to do is I need to make sure there are no remainders. Because I've got something that looks pretty good, I've got a quadratic, but there may be remainders. The same way if you did 10 divided by 3 with the bus stop method, you would end up with a remainder of 1. We need to check there are no remainders. How do we do that? Well, I do the whole process again. So I take my 3, I multiply it by my divisor, so I end up with 3x plus 3. And then I minus them. My 3x minuses my 3x, I get 0, and then I've got nothing attached to the 3, so I'm going to look back up into my equation. What have I got left? Well, I've got a 3. I'm going to bring that down here. 3 minus 3 gives me 0. And because I've got 0 here, I have got a remainder of 0. Once we get to the end, whatever we have left, so I'll show you an example in a second where this isn't 0, but whatever we have as a remainder, or whatever we have left, sorry, is our remainder. So in this case, remainder of 0, and we now know that x plus 1 times x squared plus 5x plus 3 gives me this. And just by dividing this by this, I've all of a sudden solved my cubic. I can easily solve my quadratic with quadratic formula or factorization, and immediately know the 3 roots of my cubic, etc., etc. So let's look at a bit of a harder example. We've now got 2x cubed plus 9x squared plus 25, all divided by x plus 5. So let's go through the procedure once again. So my x plus 5 is going to go on the outside, my bus stop looking thing. Then the inside, I need to write out this equation. So 2x cubed plus 9x squared, and I'm going to pause. The reason I'm going to pause is I've noticed I don't have any term that only has an x in it. I've got an x cubed, an x squared, and an integer, but I don't have anything that has an x. And later, when I start minusing things from each other, that's going to become a problem, because remember, when I get down here, I'm going to want to minus an x from another x. So how do I solve this? Well, I should immediately be noticing this point, and when I write it out here, I'm going to write it with a plus 0x. Adding a 0x doesn't change anything. It just makes the maths easier, and we'll see why in a second. Right, let's go through the procedure. Sound like Kramnik. Anyway, 2x cubed, I'm going to divide it by x. Now, I'll make it clear at this point, the reason that I'm dividing it by x is because I only have an x here. If I had an x squared, I'd be dividing it by x squared. Essentially, what I'm looking for is to divide this by something here that means when I go back and multiply, I minus it from itself. If that was a mess of words, let me show you what I mean. So we divide it by our x, and we get 2x squared. And then we multiply that 2x squared by this entire thing, and when I do that, I get 2x cubed plus 10x squared. So if this here was an x squared, and I just divided by an x, I wouldn't end up with this 2x cubed here. I need this times the first term to equal that. So that is why I've chosen x. I didn't really mention it in the first example, but I'm mentioning it now. That's why we chose x, so that I get a lovely match here, so that when I minus them, keep switching colours for the fun of it, 2x cubed minus 2x cubed is 0, plus 9x squared minus 10x squared, that's actually minus x squared. Shouldn't have been so hasty with that plus. Or I should have done 9 minus 10 quicker in my head, but can't win them all. Okay, and we repeat the procedure. Minus x squared, well, we divide it by whatever's here, that's an x, and I'm going to add that to the top, using track of the colours. So minus x squared divided by x is minus x. And then I'm going to repeat the whole thing again, minus x times all of this. So minus x times x is minus x squared. Minus x times 5 is minus 5x. Minus these from each other. Minus x squared minus minus x squared. Well, that'll cancel out and that will still give us 0, hopefully. If you're ever not getting zeros here, by the way, early on in the equation, something's probably gone wrong. Zeros at the end, non-zeros at the end are fine, they just mean we've got a remainder, but here, there might be a problem. So we've got minus x squared minus minus x squared is 0, and then, well, this 5x squared needs to be minused from something, so I'm going to bring this 0x down here. And I'm going to do 0x minus minus 5x gives me plus, what colour am I using? Plus 5x. And this is why having this 0x is so important. Because if that wasn't there and I just had a plus 25, I'd get stuck. Or I might try doing something really silly like 25 minus minus 5x, which is obviously not ideal. Right, I've got to another layer of my equation. I'm just left with a 5x, we know the drill by now. Divide that by the x, pop it on top, I get plus 5, and then multiply that 5 by everything. I'm just check where my lines are. So I get 5x plus 25. My 5x and my 5x, when I minus, go to 0. And then my 25, I'm going to bring down this number to work with, and I get 25 minus 25 is 0. So once again, I get a lovely solution with no remainders. So let's have a look at one more example that may or may not have a remainder in it. Let's have a look at this one. So this time I've already got it inside the bus stop method. I realise I didn't have anything missing. I've got a 3x cubed minus 14x squared minus 47x minus 14. Those minuses might come back to bite us a bit later, so keep track of those. So I don't need any weird zeros in there. I can just get started. I've only got an x over here, as is typical, so I can just divide this first term by x, and I get 3x squared. I'll be moving a little bit faster in this example, just so we can start to do it without the training rules on. So 3x squared times that, I end up with 3x cubed minus 9x squared. And then I minus these from each other here, and I end up with minus 14 minus minus 9. Minus 14 plus 9 is minus 5, so I get minus 5x squared. And of course, that and that become 0. Sorry, forgot about that one, I just kind of did it automatically. So I get minus 5x, so I'm going to divide that by my x, put it up top, and I get a minus 5x. Now, let's multiply that minus 5x down here, so I get minus 5x squared plus 15x. Minus them from each other, minus 5x squared plus 5x squared cancel. Bring down my 47, or my minus 47x rather, and I end up with minus 47 minus 15, and that just gives me minus 62x. Divide it by x, pop it on the top, and I get minus 62. And this tends to be where our solutions end. Usually now I would keep going, I'd get a 0, everything's hunky-dory, I've got no remainder. But let's see what happens now, because we've always got to check. Minus 62 times x minus 3. Well, minus 62 times x, that's all good, that's minus 62x. And then minus 62 times 3 is 186. So I get plus 186. Uh-oh. Usually, we get the same number here, because when I bring this minus 14 down, well, my minus 62x and minus 62x are going to cancel, so that's all good. But here, I've got minus 14 minus 186, or I've got minus 200. So in this case, this is my answer, but I have a remainder of minus 200. And this is why it's always very important to keep going to the end. Don't just get to this stage, write the minus 62 and assume we're done, because we might have something left over.